We've made a lot of progress and it's starting to look like a transmission again. It's great to have you back in class. This is Chrysler 46RE class, part 2, lesson 5. If you'll recall, in the last lesson, we installed the servo assemblies, replaced the intermediate shaft housing, attached the overdrive section, and finally installed the reverse drum, reverse band, and the planetary gear sets. The goals of this lesson are reassembly of the forward and direct clutch drums, reassembly of the pump, testing of the pump and drums together to determine if they will operate correctly, and finally installation of the pump, clutch drums, and kickdown band into the case. Get the loosely assembled forward clutch drum and input shaft, as well as the original burned up forward clutch pack. It consists of the snap ring, end plates, and the ruined friction and steel plates. Set this plastic thrust washer aside. Remove this very wavy snap ring plastic spacer ring, Belleville spring, and piston. Slide the outer housing off of the inner hub. We discovered damaged splines on the inner hub in an earlier lesson and made a note to replace it with a new one. Here it is. It is item number 22575B. Removal of the old hub requires a shop press. The input shaft is pressed into the hub with a tight interference fit. There is a hard to see wire ring located here in a groove to prevent the shaft from moving out if it were to become loose. It must be removed before the shaft can be pressed out. A mechanic's pick is the best tool to reach in and get underneath it. Set this ring aside. Let's take the new and old parts to the shop press. The shaft must be pressed out from this direction. press the input shaft in until it stops on a wide shoulder. Reinstall the small ring into its groove. Turn the assembly over. The forward clutch piston goes into its bore next. Let's get the new inner and outer lip seals from the overhaul package. Here's the inner seal. This is the outer one. Install them onto the piston. The lips of both seals should point in this direction. Apply fluid to the seals and the inner and outer walls of the hub. Set the piston onto the hub. You can use a 17 thousandths of an inch feeler gauge blade to work the lip seals into the bore, or, as we did with the overdrive piston, use a section of stiff plastic cut from a 2-liter Pepsi bottle. Roll it up and use it to funnel the inner seal in first. Then pull it around the outside of the piston with light pressure to work the outer seal in. Replace the clutch drum outer housing onto the inner hub. Set the Belleville spring into place. The plastic spacer ring goes in next. Finally, install the very wavy snap ring into its groove. Except for this flat snap ring, all of the other old components of the forward clutch pack will be replaced with new ones. Let's get the replacement end plates. Here's the new apply plate. This is the plate which goes into the drum against the Belleville spring. It's item number U22149. We will also need this end plate. It's item number U22146. The forward friction and thin steel plates have been completely destroyed from severe slippage and heat. This was caused by a clogged filter. I count 4 friction plates. I count 3 thin steel plates. The new ones are in the master overhaul section of the Deluxe Super Kit. Here are the 4 forward frictions which we need. Notice that they are almost completely smooth except for a few very shallow slots. Each one is 61 thousandths of an inch thick and has 62 teeth. This type of forward friction plate is used in all models from 1989 until 2002. The 2003 and later friction plate is different. This is what a 2003 and later forward friction plate looks like. First of all, notice the obvious waffle pattern on the friction material. The surface is not smooth like the earlier type. Also note that it has 93 teeth instead of the earlier type, which has 62 teeth. Finally, the friction material is a high energy type which can withstand high temperatures. The Deluxe Super Kit for the 2003 and up 48RE transmission will include this newer friction plate. There are a total of 8 steel plates of the same thickness in this particular kit. They are all 70 thousandths of an inch thick and will be used in not only the forward clutch, but also the direct clutch as well. We need 3 of them for now. We need to prepare the friction plates. pre-soak them. The clutch pack stack-up begins with the apply plate. Set it into the housing with this raised rounded side in first. It acts as a fulcrum pivot point against the Belleville spring. Set a friction plate in. Place a thin steel plate in. Add another friction plate. Add another steel plate. Add the other two friction and one steel plate in the same manner. There are now 4 friction plates and 3 thin steel plates in the housing. The end plate goes in next. It is flat on both sides and can be installed with either side against the last friction plate. Finally, install the flat snap ring into its groove. Acceptable end clearance measured with a feeler gauge should be between 24 and 40 thousandths of an inch. I measure 30 thousandths of an inch, which is within the acceptable range. Turn the assembly over. Replace the plastic thrust washer into the recess here. This thrust washer has a thickness of 61 thousandths of an inch. If you need a new one, it's item number 22211A. There are 3 sealing rings on this assembly to replace. Here, here, and here. The new ones are in the sealing ring sub-kit. Remove this larger diameter ring first. It is a hook type. Hold and pinch one end of the ring with your left hand and thumb. Carefully pry the other end out with your right thumb. This ring is made of tin-plated iron, which is brittle and can break if you spread it too far. Here's the new one. Install it into its groove and hook the ends together. The original smaller diameter sealing rings here and here are different in style and also made from different materials. The original ring in this location is typically made from Teflon with gaps which simply butt together. Spread the ring to remove it and set it aside. The last sealing ring on this assembly is another hook type iron ring. Carefully pinch and unhook it. Set it with the other old rings. The replacements are not only made from a different material than the old ones, but also have a different color and use a different sealing technology. They are tan colored, made from a type of plastic, and have unique ends which slide together with a zero end gap. Spread them just enough to clear the groove shoulders and install them. Set this assembly aside for now. Reassembly of the direct clutch drum is next. Get the loosely assembled parts, which include the drum, piston, return springs, spring retainer, and retainer snap ring. We'll also need the clutch pack end plate and slightly wavy snap ring. I'm going to leave the friction and thin steel plates here. These are actually new parts which I temporarily installed in order to demonstrate what the clutch pack should look like. The original plates were too badly damaged and distorted to use. Note that there are 3 friction plates and 3 thin steel plates. Set the return springs, retainer, and snap ring aside. We need to go back to the parts bench and get the old lip seals which we removed from the piston and the groove in the drum during the disassembly in part 1. Here they are. Installation of the direct clutch piston into the drum requires a different technique from how we installed the piston in the forward drum. You will not be able to use a feeler gauge or stiff plastic to shoehorn the seal which goes here into the drum. You can't reach it. There is a method to do it without using those tools. In order to demonstrate, we'll practice using the old lip seals. Install the old piston seal with the flare pointing downward into the drum. Install the old inner seal into the groove in the drum with the flare pointing downward also. Put fluid onto the seals. Put fluid, or preferably transgel, onto the inner bore of the piston and the bore of the drum. Make sure that you lubricate this chamfer at the entrance to the piston bore. Set the piston into the drum. Rotate it back and forth as you push it down. Maintain even pressure around the piston and it will eventually go down into the drum. It will take patience and some finesse to work the piston in. Don't force it with too much pressure. You want to use only enough downward pressure to let this chamfer funnel, or in other words, shoehorn the flare of this seal into the bore. The inner seal will automatically install. Once again, this procedure takes patience, so work slowly to avoid forcing the piston in before the seal has had a chance to funnel into the drum. Once the piston goes down into place, you should be able to move it back and forth like so. If it feels as if the piston is wedged in too tightly, remove the piston by turning the drum over and slamming it down onto the bench. Rock the piston back and forth to remove it. Remove the old lip seals. The new ones are in the overhaul package. Here is the larger diameter piston lip seal. Here is the smaller diameter lip seal, which goes into the groove in the drum. Install the new ones. As we did before, add fluid to the seals. Put transgel or fluid onto the drum walls. Set the piston in and rotate it back and forth. Because the seals are new and flare out more, you may need to apply a little more pressure to compress the lips of the seals inward. It will eventually go down into the drum. You should should also be able to rotate the piston back and forth. Set the return springs into place. Arrange them in groups of 3 with 2 empty pins between each group. Note that the total number of springs may vary depending upon which model you are working on. Always arrange them evenly. Set the retainer on top of the springs. The outer lip should go downward. Take the drum assembly and the retainer snap ring to the shop press or to the homemade spring compressor which we used during the disassembly. Set the drum onto the tool. Compress the retainer about 1/4 of an inch past the snap ring groove. Use snap ring pliers to spread and install the snap ring. Remove the drum from the tool. Let's get the friction and steel plates from the kit. Here they are. All direct clutch friction plates have a waffle type surface. They may be beige in color as these are, or a dark green color. They are considerably thicker than the forward friction plates, measuring 95 thousandths of an inch thick. This kit comes with 4 direct clutch friction plates. We only need 3 for our particular model. We also need 3 of the thin steel plates. Let's prepare the friction plates with fluid. Pre-soak them as we did with the others. Begin the clutch pack stack up by placing a thin steel into the drum against the piston. Set a friction plate in next. Add a thin steel plate. Add a friction plate. Set another steel plate in. Add the last friction plate. Depending upon which model you are working on, the direct clutch drum may require 3, 4, or even as many as 5 friction and 5 thin steel plates. The last plate should always be a thick end plate. Finally install the wavy snap ring into its groove. The end plate clearance should be between 95 and 165 thousandths of an inch. This generous amount of clearance may seem excessive or even sloppy at first, but it is normal and actually necessary for the transmission to shift correctly. It has to do with timing during the transition from second to third gear. In other words, the wider end plate gap in this clutch gives the kickdown band enough time to release before the direct clutch is applied. Adjusting the end plate tighter can cause a bind-up during the shift. Do not attempt to adjust the clearance tighter than 95 thousandths. Maintaining this loose end plate is even more critical if you are installing a shift kit for high performance use. For now, turn the drum over and set it onto the forward clutch. Get the pump. If you haven't already done so, remove the pump to case O-ring and leave it with the old pump to case gasket. Set it onto the bench with the front seal and stator support splines downward. Remove the 6 bolts which fasten the stator support to the pump body and set them aside. Lift the stator support off of the pump body, turn it over, and set it aside. Lift the pump rotors up and out of the rotor cavity, turn them over, and set them down as removed onto the support. We need to replace the front seal and the bushing which supports the torque converter hub. Let's take the pump body to another work area. Set it onto blocks of wood in order to protect this plastic structure. This is the vent for the transmission. Use a hammer and large screwdriver to collapse and remove the front seal. Before driving out the bushing, make a mental note of how it is staked in two places. The bushing has been peened with a tool to produce two tangs which prevent the bushing from walking forward into the front seal. Use the same tools to drive it out. We need a new pump bushing. A new bushing comes in the Deluxe Super Kit. The 46RE family of transmissions use a unique type of bushing in the pump. Notice the dimple-like pockets on the inner surface. Even though a smooth, non-dimple type bushing used in the TorqueFlite 727 has the same dimensions and will actually fit this pump, it is not the correct type for this transmission. Always insist on using this dimpled type bushing because of its superior ability to retain fluid. Try to find a sturdy device such as an engine valve or large socket to use as a driver. I have modified a large stubby screwdriver to use as a tool to reproduce the peen tangs in the bushing. I simply used a bench grinder to remove most of the flat blade until the end was about 3/16 of an inch wide. It's a good idea at this point to test fit the pump body onto a torque converter hub. Set the body over the hub of the converter to make sure it can turn freely. If it feels tight, place a block of wood against it and tap the wood with a hammer in several different places. This will knock down any high spots on the bushing. Lubricate the pump rotor cavity and rotors with Transgel. Turn the rotors over and set them in. Center the inner rotor with the pump bushing. Pack more Transgel into the gap between the rotors. This will help to hold the inner rotor centered, making torque converter installation much easier later. Set the stator support into place and replace the 6 bolts. Tighten them to 15 foot-pounds or 20 Newton meters. There should be a plastic thrust washer in place here. At first it may appear to be exactly like the one which goes between the forward and direct clutch. It does have the same inner and outer diameter, but it is typically thicker. The most common thrust washer in this location will measure 84 thousandths of an inch thick. A replacement is available if you need one. It is item number 22211B. The 2 sealing rings located here must be replaced. They are the type you must pinch and unhook. The exact same type new ones are in the sealing ring subkit. Carefully spread them only enough to clear the shoulders of their grooves. Add fluid to the rings as well as the thrust washer. The pump and drums can be temporarily assembled together in order to test the hydraulic passages, lip seals, and sealing rings for unacceptable leaks. This port is the entrance to a passageway which leads to this port on the direct clutch drum. This port is for the passage which feeds the forward clutch drum. It's possible to duplicate the hydraulic application of these clutch drums by substituting air pressure to apply them. Set the direct clutch drum onto the pump like so. If you do not have access to shop air pressure, consider using a portable air tank along with a pressure regulator and rubber tip blowgun. Make sure that you are wearing eye protection. Reposition the pump so that the clutch drum faces away from you. Insert the tip of the blowgun into this port and apply about 75 pounds of air pressure to it. The clutch pack should apply with only a small amount of air leakage. The test confirms that the lip seals and sealing rings, as well as the clutch pack, are working correctly. The drum should turn freely but not have excessive side play. In other words, if you can wobble yours any more than the drum does in this demonstration, you need to replace the bushing with the one which is in the kit. You can drive it out and replace it as we have with the other bushings. Let's test the forward clutch. Put transgel onto one side of this thrust washer so that it will remain in its recess. Adding transgel to this sealing ring will help it seal during the air test. The forward clutch drum is completely installed when the teeth of the 3 direct clutch friction plates have splined with and engaged the teeth of this inner hub. This thrust washer should also rest against this surface of the direct drum. Also be aware of a piston effect as a result of this sealing ring having a larger diameter than this ring. Hydraulic pressure between these rings will not only apply the forward clutch piston, but also apply force against the intermediate shaft. In other words, the forward clutch drum will try to pop out of the pump as we test it. Rotate the clutch back and forth to engage the 3 friction plates. Place a towel under your palm to prevent being pinched as you hold the drum down during the test. Apply air pressure to this port. You may hear some air leakage during this test, but the clutch pack should apply as this one does. This 3-load pocket is for a small but very important 3-tab thrust washer. We placed it in the small parts box during the disassembly. Here it is. Also get the very important circular hardened steel washer which mates with it. The uneven spacing between the tabs prevents it from being installed incorrectly. It will only go in one way. The bronze surface faces outward. Put transgel on the back of it and set it into place. This hardened steel washer is the thrust surface for the 3-load washer. Simply set it into place on the end of the intermediate shaft. Put fluid onto the thrust washer here. Add more transgel or fluid to the sealing rings on the input drum. We can now install the clutch drums into the transmission. The splines of the 4 forward friction plates must line up with and engage the splines of the input ring gear. Rotate the input shaft back and forth until the lugs on the direct clutch drum go down into the notches in the drive shell. The kickdown band goes in next. The original kickdown band is in good condition, but we'll replace it with a new one which comes in the kit. This is the new kickdown band. The lining is a friction material that must be pre-soaked with fluid. Dip it into fluid as we did with the friction plates. Set it in like so for now. Get the pump to case O-ring and the pump to case gasket. Put transgel or bearing grease onto the sides of the pump bore. Set the gasket into place. Install the O-ring into its groove around the pump. Put fluid or transgel onto the O-ring, bushing journal, sealing rings, and the bore for the forward clutch sealing rings. Align the pump passages with the ones in the case and lower the pump into place. Get the 7 pump to case bolts. They are 1 5/8 of an inch long and have 1/2 inch heads. Remove the old sealing ring washers from each bolt and replace them with the new ones in the miscellaneous kit. Start all of the bolts. Pull the pump down into place by moving around in a star pattern as you tighten them with a 1/2 inch socket, extension, and ratchet. snug them lightly for now. Check to make sure the input shaft will turn freely. Pull up on the input shaft. There should be some in play. If you cannot turn the input shaft and it feels locked down, remove the pump and check to make sure that all of the friction plates in both drums have splined with their inner hubs. Use a torque wrench to tighten the pump to case bolts to 15 foot-pounds, 220 inch-pounds, or 20 Newton-meters. Pull up on the shaft and measure the clearance between the pliers and the end of the stator support with a stack of feeler gauge blades. The acceptable in-play range is between 35 and 85 thousandths of an inch. We need to install the two struts for the kickdown band. We place them in the box during disassembly. Set this strut into place like so. Install the longer one between the servo lever and band lug. Begin tightening the adjustment bolt. Lightly tighten it with a 5/16 open wrench. The final adjustment varies depending upon which model you are working on. Back out the bolt 2 3/4 turns on 46RH and 46RE models. Back it out 1 7/8 turns on 47RH and 47RE models. Back it out 1 3/4 turns on 48RE models. Hold the bolt with the 5/16 wrench to prevent it from turning as you lightly tighten the lock nut with a 3/4 inch wrench. Finally, finish tightening the lock nut to 25 foot-pounds or 34 Newton-meters. This concludes the assembly of the transmission drivetrain. But before I end this lesson, let's use air pressure in an interesting way to test our progress. You can watch and test how the bands apply by applying shop air here to charge the reverse band servo and here to apply the kickdown band servo. You can also listen to the clutch packs as they apply. The port in the case at this location is for the forward clutch. This port is for the direct clutch. I want to congratulate you for reaching this point in your transmission project. You now have a very healthy, solid foundation for a long-lasting, tough transmission. In the next lesson, we'll work on the valve body.